Greetings, everyone. I want to welcome you all attending today. On behalf of our team based in North Andover, Massachusetts, and my colleagues around the world, thank you for choosing to spend a few minutes learning about Gefran. Not only do we make pressure transducers, linear potentiometers, magnetostrictive linear sensors, and strain gauges in designs that plastics OEMs desire, we have a wide range of 21st century solutions for precise temperature control and power control by SCR. Today, we will present information about melt pressure transducers and transmitters, a core competency within Gefran. I would ask that everyone mute your audio now. We want you to ask any questions you have in a live question and answer session at the end of the presentation. Melt sensors provide pressure and temperature feedback to monitoring and control systems typically found on equipment that extrudes, molds, or forms plastic and polymer. For the purposes of making better product and making that better product consistently, having accurate and robust instruments is important. We also employ these sensors to minimize downtime and best assess the health of the equipment and process. Furthermore, the safety of employees and machinery can be enhanced by monitoring melt pressure. There are quite a few variables that must be considered in order to have an optimal experience with such a delicate instrument. In particular, if you are not having that optimal experience with the sensor you use now and you need to choose an alternative, it is an opportunity to review all these conditions and make a more precise choice based on conditions that might be more specific to you and your application than to the original OEM design. For instance, mercury may no longer be allowed in the plant. Process temperatures may lead you to a different fill option too. As this slide illustrates, mercury is good up to 400 Celsius. The FDA-approved oil is good to 315 Celsius. The sodium-potassium fill is good up to 538 Celsius with the right diaphragm. The contact medium may suggest a different diaphragm material or thickness. Required accuracy and observed temperature drift will demand attention in the selection process too. Briefly, a melt pressure sensor works like this. Installed correctly, the hot diaphragm deflects as it comes into contact with the medium. The deflection affects a capillary filled with one of a number of substances that then affects the cold diaphragm. Gefran is moving gradually away from strain gauges and toward a design where the cold diaphragm interacts with thick film resistors that are screen printed and arranged onto stainless steel in a Wheatstone bridge configuration. This creates an electrical signal that can be scaled, amplified, and passed to displays and control systems. In addition to this extensometric sensor design, Gefran has also developed a piezoresistive, solid-state, fluid-free melt sensor called Impact that provides more performance than any other sensor on the market and eliminates any concern over fill material. It is operable at operating temperatures as high as 350 Celsius. It features a diaphragm many times thicker than a standard melt sensor, ideal for challenging mediums and long duty cycles. It has a floating hex nut, allowing for easy installation. Temperature compensation is built in, and a PL Level C version is available. The materials used to construct and coat diaphragms is of great importance. Abrasion, corrosion, and adherence are reasons to consider custom solutions, but Gefran designed our GTP Plus coating to optimize any standard sensor for such concerns. Gefran accounts for all these sensor variables in a part code breakout like this. The first digit determines the model and associated fill. Here we use K for sodium-potassium. Next is the digit that indicates the output signal. Here it is E, representing 4 to 20 milliamps. The third digit indicates presence absence of the rigid stem and armored flex. The number 1 represents that both are present. The fifth digit indicates the pinout of the connector. The 6th pin is more common. The 6th digit indicates the accuracy level. M is standard accuracy at less than 0.5% full scale output. The next 4 digits will indicate the pressure range and the unit of pressure measurement. P05M represents 5,000 psi. Those are followed by the digits for thread size, rigid stem length, and flex length respectively. 1,4D represents a half 20 thread, a 6-inch stem, and 18 inches of flex length. There are a set of suffix digits that can go further to customize the sensor to the customer's needs in many ways. This particular suffix has a modification code that calls for an Inconel diaphragm of a particular design. You can expect certain features to be available to you when employing Gefran melt sensors. In addition to the diaphragm coating options, we offer an easy-to-use solution for zeroing the sensor after it has been installed and the medium brought to temperature. ATEX and soon FM-approved versions allow for safe application in hazardous locations like those found in polymer production facilities. SIL2, PL levels C and D are available for enhanced safety for personnel and machinery. CanOpen, HART, and IO-Link versions allow for more and better data to be conveyed intelligently and more quickly. SIL, or safety integrity levels, are determined by identifying hazards and assessing their risk. There is no method or scoring system. Rather, a producer or user will simply use their own data to determine an acceptable level of risk mitigation they wish to apply. Gefran produces products with a SIL2 rating, which is becoming more commonly demanded in industrial applications, as well as OEM designs for mobile hydraulics. It illustrates how different levels of safety integrity level rating allow for assumptions about reliability and outcomes. Performance levels are a product of the EU and seek to identify the potential severity of an injury for a hazard, to determine the frequency of exposure to that hazard, and what possibility there is of limiting that hazard. As you can see, part of this ISO machinery directive speaks directly to extrusion and the need for safety related to maximum pressure. A performance level C rated melt pressure sensor eliminates the need for a burst plug. The analog circuit is certified, making it preferable in the control of equipment like melt pumps. The sensor will be capable of self-diagnosis, as illustrated here. The information is available as a variation in that certified analog output. These performance level rated products provide for an optional integral safety relay that can make self-diagnosis easier, and it can actuate a shutoff. Melt sensors can be directly wired into a PLC or machine controller, but their signals are often retransmitted to a PLC from a discrete device like a display by way of process signal or communication. Gefran offers a variety of displays for this purpose. The 40B scales and displays a value from a strain gauge input. The 40T scales and displays a wide variety of linear inputs. The 40TB can take inputs from strain gauge sensors and thermocouples and display both pressure and temperature values at once. The Gefran 2400 display can show you two independent pressure inputs. This 2500 series is a powerful process controller with two independent pressure inputs and the ability to display both of them, along with a third line for a delta or some other information. All of these instrument examples have at least two alarm outputs and can be retransmitted via process signal. Some can be equipped with Modbus RTU, and some have transmitter power supplies that are available on board. The fourth industrial revolution, referred to as Industry 4.0, is about connecting the physical world of manufacturing to the digital world of AI, cloud computing, and highly advanced data-driven decision-making. IO-Link is a standardized communication protocol that leads the way to maximizing the collection of data, both cyclic and acyclic, from sensors enabled to provide more than their signal output. Gefran is proud to announce we are the first company in the world to produce an IO-Link melt pressure sensor. Why a melt pressure transmitter with IO-Link? What additional benefit can an IO-Link capable melt sensor provide? Please stay tuned. Gefran's new product presentation schedule has been released. We plan to present IO-Link separately and comprehensively in the near future. So from all of us at Gefran, we thank you again for your time and attention. We want to address any immediate questions you have. Please remain in the meeting and ask your question live with our support team, or email sales.us@gefran.com if you prefer to ask on your own schedule. Our team will find the best available support member to address the questions you have, regardless of their technical or commercial nature. This concludes today's presentation. Stay tuned for that live question and answer session.